Okay. So we are learning the next set of rules. The product rule and the quotient rule. So now instead of really rewriting the function, although you could distribute s to the 1/2 power, but rather than doing that, we're going to use this product rule that is used to find the derivative of a function that has something times something else. Okay? The product rule is this in word formats. It's the first, and this will just be kind of the shortcut phrasing that I use. It's the first, meaning the first function, times the derivative of the second, plus the second, meaning the second function, times the derivative of the first. So you'll hear me say that phrase a lot. First times the derivative of the second, plus second times the derivative of the first. Okay? It's a mouthful. You'll get used to it. It's pretty quick. Down at the bottom, you'll see it in notational form. If we want to take the derivative of the product of two different functions, that will equal, here's your first function, times the derivative of the second, g prime of x, plus the second function times the derivative of the first function. Does that make sense? Okay, so our two functions here, this would be our first, and this would be our second. Now, if you want to, because you know you're going to eventually have to take the derivative of either piece, you can rewrite this, if it's more helpful to you, as s to the 1/2 times 4 minus s squared. So now, applying the product rule, g prime of s is going to equal the first times the derivative of the second. What is the derivative of this piece? Paul.
Negative 2s.
Right, minus 2s. So first times derivative of the second, plus your second, times the derivative of your first. What is the derivative of s to the 1/2 power, Lauren?
1/2
Perfect. And then it's all cleanup. And so with that, I'm probably going to change my s to the 1/2 power back to a radical. So this will be negative 2 root s, oh no, sorry, negative 2s root s. We'll cover this first piece. Plus, and then with this one, I'm going to move this back to the denominator of its piece. So I can keep my 4 minus s squared, but this is going to be 1 over 2 root s. And that's fine. We're not gonna rationalize here. We're going to, gosh, that looks like a 5. The only thing I can do with this one is I can just multiply this by the 1 and kind of put that in the numerator. So to make it as clean as possible, negative 2s root s plus 4 minus s squared over 2 root s. And that's my derivative. Okay. Any questions on that one? Ugh, right?
I don't like that.
No, I don't either. I don't like that either. Okay, the next one. There's our function. I should have called it something. Let's call it f of x. So so that we can properly notate the derivative. So the derivative is going to be, do you see our two functions? The first function, well, the first piece of the product is root x. The second piece of the product is sine x. So when I say the first, I'm talking about root x times the derivative of the second. What is the derivative of sine? Cosine. Plus the second function, the sine x, times the derivative of the first. And again, if you want to rewrite that as x to the 1/2 power, that can sometimes make it easier to come up with a derivative. Bring your 1/2 out in front, x to the negative 1/2. Then we clean up. This is just root x cosine x. And then this is going to be, I'm going to move this into the denominator. And at the same time, I'm going to do the sine x times 1 in the numerator. So it will be sine x over 2 root x. And that's your derivative. I suppose if it is a multiple choice, what you might see is some consolidation and adding these together. So if I put the first term over 1 and get a common denominator, I'm just going to show you that in case we have to do it. So on the first term, getting a common denominator, what does that do to our numerator? What's 2 root x times root x? 2x. That's going to make my numerator 2x cosine x plus sine x all over the common denominator of 2 root x. And I think we would all agree that that is a cleaner version of it. Whereas in number 1, we did not get the common denominator. We could have there as well. We did not. But just in case you might have to make your multiple choice match, there it is. Okay? Any questions on that? The next two examples are the quotient rule. So rather than being the product of two things, we have the quotient of two functions. So you will hear me say this for the, and I'll write it up top again, for the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over bottom squared. So that phrase will just fly out of my mouth pretty fast. Bottom times derivative of top minus top times derivative of the bottom, all over the bottom squared. Again, at the very bottom of the note sheet, we have that in proper notation. So here we are trying to find the derivative of a quotient of two different functions. So you see the bottom, g of x, times the derivative of the top, f prime of x, minus your top, f of x, times the derivative of the bottom, g prime of x, all over bottom squared. Okay? So if we jump to that first example, and the key here is organization, writing neatly, algebra skills, to make sure you're simplifying things appropriately when we get there. But for starters, we're just going to plug in appropriately. So we have our bottom. I'll do g prime of t equals. The bottom is 2t minus 7 times the derivative of the top is just 2t minus the top, t squared plus 2, times the derivative of the bottom, which is just 2, all divided by bottom squared, 2t minus 7 squared. Okay, so to clean this up, I'm going to distribute here, and I get 4t squared minus 14t. I'm going to keep that in brackets, just for organizational purposes. I'm going to keep my minus sign a minus sign, and then I'm going to distribute my 2 as well, keeping this in brackets. Why am I definitely keeping this in brackets? Right, because I will eventually have to distribute the negative. All over, and I'm just going to leave my bottom alone for now unless I see a need to do something with it in a minute. But I do now want to distribute my negative sign and combine like terms. So 4t squared minus 2t squared is 2t squared. Negative 14t is subtracting. There's no other t term, so that's just remaining a negative 14t. And then minus 4. Okay, if this thing is going to simplify any further, it's not going to be from squaring out the denominator, right? It's going to be from trying to do what with the numerator? At least try to factor the numerator. Now I know I can for sure take out a 2. But then the trinomial I'm left with is definitely not factorable. So if it was, perhaps it would be factorable into a 2t minus 7 and something else. That way I could cancel and simplify this a little bit. But it can't be factored any further, so this would be our final answer.
Where does the Z come from?
Z, that's a 2.
Oh, okay.
My Z's, I put little things in the middle of them.
It looks like a Z.
I know, but that's why I do put a little, like when I do a Z, I do that so I don't confuse it with a 2. Those math people got all silly ways of writing things because it just takes, oh, you do. Yeah, I just never did 2's that way. Well, I guess I did. I switched up with my 2's. Alright, so there's that quotient rule. Okay? What do we have on the back? Let's jump to the back. We'll do one of the quotient rule. We'll do this one. The back, same thing. We're going to still need to differentiate. It wants us to find f prime of x and then also f prime of c. So find the derivative and then evaluate the derivative at c. So we'll touch upon this c in a minute. But f prime of x, following the quotient rule, is going to be the bottom, times the derivative of the top. What's the derivative of sine? Children? Cosine. Bottom times derivative of the top, minus the top, times, what's the derivative of the bottom here? What's the derivative of x? 1. All over bottom squared. So if I clean that up, I just have x cosine x minus sine x all over x squared. Good enough. Now to find the value of the derivative at pi over 6. F prime of pi over 6. And I'm just plugging it in. So that's pi over 6 times the cosine of pi over 6 minus the sine of pi over 6 all over pi over 6 squared. What's the cosine of pi over 6? Nope. Root 3 over 2, good. And the sine of pi over 6? That is 1/2. And pi over 6 squared, you could write it as pi squared over 36. I'm actually just going to keep it. No, I'll make it pi squared over 36 because I've got a complex fraction, so I'm going to want to keep change flip if I can. So this right here This is pi root 3 over 12, yes? And this, if I want to get a common denominator, is technically minus 6 over 12. So my numerator is pi root 3 minus 6 over 12. So if I keep, change, and flip, does anything cancel? You can't, because this pi is part of a binomial. But I'm glad you said that, because it can never hurt to remind ourselves of that. What can reduce? Right, the 12 and the 36 would just become 1 and 3. So when this is all said and done, it's going to be 3 times pi root 3 minus 6 all over pi squared. That's the value of our derivative at pi over 6. Good? Any questions? All right. I just have 2 examples at the bottom for you to try. Obviously, there were some things along the way we also didn't get to. But pick which one you want to practice, the product rule or the quotient rule, and I want you to do these 2 at the bottom. While you guys are doing those 2, I'm going to just fill these in up here. But I want you to work on, pick one of the bottom 2, and then I'll randomly pick one of each type to look at. Yes? Oh, shoot. Thank you. So that should be plus 2, plus 2, plus 2. Oh my gosh, look at that. Would you look at that? It ended up being 0. Did you finish the 2 on the bottom? And you're having time to audit my work? You're unbelievable. What an all-star. If I had all-star pins, I'd give one out to Aaron. How did I do on the second one, Aaron? Okay. Raise your hand if you finished at least one of the ones on the bottom. Maggie, which one did you do? The first one. Did anyone do the second one? Okay. Let's take a peek at Maggie's. She has product rule. She's got the first times the derivative of the second, perfect, plus the second times the derivative of the first. So she multiplies that out, 18x cubed plus 15x squared, perfect, plus 6x cubed minus 12, great. Combine like terms, excellent, and then she factored out a 3, which you may or may not do. It depends on if it's a multiple choice question or not, but good. Any questions on that? There's your derivative. And then on the second one, we have the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared, and he squared it out already. So we did root s minus 1 times root s minus 1 plus 1, which looks good. So on our numerator, we just have root s minus 1, and then this becomes, oh boy, how did this become that? This moves to the, that should be an s on top over 2 root s. Do we follow that? So this had to move to the denominator, so it would be s over 2 root s. And then it's still all over. I probably wouldn't square that out. I know you did. I would just probably leave it as root s minus 1 squared. And then if we want to clean up the complex fraction from there, we can. But your homework's there at the bottom. Okay? The second review packet that's online for your Friday quiz is on the product and quotient rule, so you could also get started with that. And if you have any questions on any of those packet problems, I'll field those questions tomorrow. Okay?
What I did there is the s and then the negative 1/2, I just added them by exponent rules, and when you x plus 1/2, like when you multiply it, it's like 1 minus 1/2, so it comes to still 1/2.
Oh, and I don't have that exponent rule done there.
Yeah, and that's why it was all like in one. I think this is the answer.
So it was, we think it was probably right. But
Yeah.
I erased it now so I can't see. So now you've got this one?
Yeah, I think
I'll have to look at it.